Great day, learners! Welcome to the third part of this week's session. So far, how is your experience in factoring polynomials? I know you are doing a great job. From the previous video, you've learned about factoring perfect square trinomials. But this time, we will learn about general trinomials because there are instances that the trinomial is not a perfect square but can be factored. But before that, let's have a quick exercises. Let's enumerate the pairs of factors whose product is equal to the given number. In this case, can you think of the pairs of factor which is equal to 12? Yes, we have 1 and 12, 2 and 6, 3 and 4. Remember that a positive number can be a product of negative numbers. So for this one, we can also have negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. Let's have another one. Can you think of the pairs of factors of negative 18? Remember that a negative number is a product of a positive and a negative number. Therefore, the pairs of factors are of different signs. We have 1 and negative 18, negative 1 and 18, 2 and negative 9, negative 2 and 9, 3 and negative 6, and finally negative 3 and 6. How was it? Were you able to follow? Alright, if that is the case, we can now use this concept to factor general trinomials. Let us start off with x squared plus 2x minus 15. The first thing that we should do is to identify the leading term, middle term, and the last term. Using this trinomial, the leading term is x squared, the middle term is 2x, and the last term is negative 15. Since the first term or the leading term is x squared, we know that the factoring must take the form x plus blank times x plus blank. We know that it will take this form because when we multiply the two linear terms, the first term must be x squared, and the only way to get that is to multiply x by x. To finish this, we just need two numbers that need to go in the blank spots. But how do we get that? Let's focus on the last term. Our last term is negative 15. Just like what we did in the quick exercises, we need to get the pairs of factors of negative 15. Can you give me those pairs of factors? Remember that the pairs of factors of a negative number are of different signs. In this case, we have 1 and negative 15 and negative 1 and 15. We also have 3 and negative 5 and negative 3 and 5. After identifying the pairs of factors of negative 15, let's look at the middle term. The numerical coefficient of 2x is 2. Among the pairs of factors, which pair can give us the sum which is equal to 2? 1 plus negative 15 is negative 14. It is negative because it will take the sign of the bigger number. Negative 1 plus 15 is equal to 14. The sum of 3 and negative 5 is negative 2. And the sum of negative 3 and 5 is 2. Can we now identify which among the pairs of factors whose sum is equal to 2? Alright, negative 3 and 5 is the right pair of factors. We can now use the right pairs of factors to fill on the blank spots. We are done with our first example. Did you follow the steps correctly? Why don't we try another one? This time, let us have x squared minus 10x plus 24. Again, our first step is to identify the leading term, middle term, and last term. Using this trinomial, our leading term is x squared, our middle term is negative 10x, and the last term is 24. Since the leading term is x squared, we can write the initial form again, which is x plus blank times x plus blank. Again, we know that it will take this form because when we multiply the two linear terms, the first term must be x squared, and the only way to get that is to multiply x by x. Now, let's get the pairs of factors of 24. We have 1 and 24, negative 1 and negative 24, 2 and 12, and negative 2 and negative 12. We also have 3 and 8, negative 3 and negative 8, 4 and 6, and negative 4 and negative 6. After identifying the pairs of factors, we get the numerical coefficient of the middle term. This time it is negative 10. Among the factors of 24, which pair can give us the sum of negative 10? 1 plus 24 is equal to 25. Negative 1 plus negative 24 is equal to negative 25. 2 plus 12 is equal to 14. Negative 2 plus negative 12 is equal to negative 14. The sum of 3 and 8 is 11. The sum of negative 3 and negative 18 is negative 11. The sum of 4 and 6 is 10. And the sum of negative 4 and negative 6 is equal to negative 10. Which pair has given us the sum of negative 10? It is negative 4 and negative 6. With that, we can now use this pair of factors to fill the blank spots. Thus, the factor of x squared minus 10x plus 24 is equal to x minus 4 times x minus 6. Did you get better in answering our second example? Note that the method we use here will only work if the coefficient of x squared term is 1. Let us have this trinomial 3x squared plus 5x plus 2. How is this different from the previous examples? This one is different because there is a number other than 1 in front of x squared. What does this mean? This means that not only do you need to find the factors of c, but also a. Now, let's try to factor this trinomial. Our first step is to determine the leading term, middle term, and the last term. The leading term is 3x squared. The middle term is 5x, and the last term is 2. Now, let's get the product of the leading term and the last term. In this case, we have 3x squared times 2, which is equal to 6x squared. After getting the product of 6x squared, we will find its pairs of factors. We have x and 6x, negative x and negative 6x, 2x and 3x, and finally negative 2x and negative 3x. After getting the pairs of factors, let's focus on the middle term, which is 5x. Among the factors of 6x squared, which pair has the sum that is equal to 5x? X plus 6x is equal to 7x. Negative x plus negative 6x is equal to negative 7x. 2x plus 3x is equal to 5x. And negative 2x and negative 3x is equal to negative 5x. Among the pairs of factors, 2x and 3x has a sum that is equal to 5x. After getting the right pair of factors, we will replace 5x by 2x plus 3x. After replacing 5x, we now have 3x squared plus 2x plus 3x plus 2. We may now solve through factoring by grouping. We group the first two terms and the final two terms. If we can observe, we can factor out x from the first grouping, so it becomes x times 3x plus 2. The second grouping stays as there is no common factor. As you can see, we have a common factor, which is 3x plus 2. Therefore, we can rewrite it as 3x plus 2 times x plus 1. And that is it. The factor of 3x squared plus 5x plus 2 is equal to 3x plus 2 times x plus 1. And that is it for factoring general trinomials. I hope that you have learned a lot from this session. But before we part ways, let's have a quick recap. To factor a general trinomial in the form x squared plus bx plus c, we follow these steps. First is to write it in the form x plus blank times x plus blank. Second, determine the leading term, middle term, and last term of the given trinomial. Third, find the pairs of factors of the last term. Fourth, identify which among the pairs of factors has a sum that is equal to the numerical coefficient of the middle term. And last, use the right pairs of factors to fill out the blank spots. To factor a general trinomial in the form ax squared plus bx plus c, we follow these steps. First, determine the leading term, middle term, and last term of the given trinomial. Second, multiply the leading term and the last term. Third, find the pairs of factors of the product of the leading term and the last term. Fourth, identify which among the pairs of factors has a sum that is equal to the middle term. Fifth, use the right pairs of factors to replace the middle term of the original trinomial. And last, proceed to factoring by grouping. Factoring general trinomials takes some practice. I am sure after a while you will get used to it. With that, let's wrap up the session with the practice exercises. Now bring out your pen and paper and let's solve together. Write the factors of the following trinomials. I'll be giving you 15 seconds in each question. If you think that it is not enough, you can pause this video to finish your solution before we reveal the right answer. Let's start! How many items did you get correctly? Who among you scored a perfect score? Wow, you are off to a good start. Who among you got a score lower than 4? Don't worry, you are also off to a good start. You just have to review your solution, check what went wrong, and redo it. Remember that it is not how fast or how long you do it. What matters is you keep practicing until you can do it. There is nothing wrong with learning at your own pace. Anyway, this has been Teacher Mark saying that math matters.